In this video, we're going to use a calculator to solve the following equations on the interval from 0 to 2 pi. And we're going to round the answers to 2 decimal places. So once the answers, again, in radian measure. I've done some where I did the solutions in degree measure and then I converted it to radians. This time, I don't anticipate exact answers. So I'm going to use the calculator and leave it in radian mode. And then I want to remind you first here that this angle right here is 90 degrees, or in radian measure, it's pi over 2. If you divide the 2 into the pi, which is approximately 3.14, we get 1.57 radians. That's the same thing as 90 degrees. Now, this angle over here is 180 degrees, and in radians, that's pi. And we go all the way over here. That's 3 pi over 2 radians. And that's approximately 4.71 in radians again. And of course this angle right here, the positive x-axis corresponds to 0 radians, or 0 degrees. Consider that when we work these problems in. Let's go back up here then. So the calculator is in radian mode. So for this one over here, the first one then, I take cosine inverse of both sides. Cosine inverse of the left side will just give me theta. And then cosine inverse of negative 0.9, or just negative 0.9. We'll do that in the calculator. So I'll get my second key here and then hit cosine inverse and then negative 0.9. Hit enter. I get 2.6905 and so on. Now that's larger than 1.57, which is 90 degrees in degrees. And of course, it's less than pi, which is approximately 3.14. So this angle falls in quadrant 2. And in quadrant 2, the cosine of an angle is negative. So that does satisfy the condition. So I just say this is going to be 2.69. So that angle is somewhere over here. The angle terminates over here somewhere in quadrant 2. In quadrant 2, the cosine is negative, and in quadrant 3, the cosine is negative. So normally when you work these kind of problems with, especially when you just have don't have multiple angles like 2 theta or 3 theta, you expect most of the time 2 solutions. So the other angle will be somewhere in quadrant 3, because that's where the cosine is negative. Basically then, this is 2.69, and then I want this reference angle right here. What's this reference angle there? Well, to get it, I'm going to simply subtract this number here, this 2.69 from pi. So all the way over here, that's pi, and then subtract this reference angle there. This will give me then second pi, subtract that number right there, so that's the answer. So second answer, the previous part, and I get 0.4510 and so on. So the reference angle, this reference angle right there is 0.4510 and so on, and then this angle right here is also that same angle. So to get the angle that terminates in quadrant 3, I add pi. to this answer. It's going to be this answer, it's going to be pi, and then that reference angle. So I'll just say plus, I'm adding pi to that. And I get that. And those are the two angles for that equation. So it round out to two places, so this will be 3.59. 3.59. So two answers again, 2.69 and 3.59. And then for this one, I'm going to add 9 to both sides. Or I should say negative 9 to both sides. Negative 9 here, negative 9 here. 9 cancels over there. I get 5 tangent theta equal negative 9. Divide both sides by 5. I get tangent theta is equal to negative 9 fifths after dividing by 5. We're taking tangent inverse of both sides. Tangent inverse of tangent theta gives me theta, and then tangent inverse negative 9 fifths. We do that in the calculator. So we get second, and then tangent of negative 9 divided by 5. Hit enter. And I get negative 1.06 and so forth. Okay, so that angle, because it's negative, it's clockwise rotation. That'll be in quadrant 4. But remember, we want angles in the interval from 0 to 2 pi, so we can't use a negative. But remember, the period of the tangent function is pi, so I'm just going to add pi to that. That should give me another solution. Remember, you have one solution to an equation, you have an infinite number, because all you have to do is add the period multiple times and so forth. So I'm going to say, let's add pi to that. I get 2.077 and so forth. That's what? That's an answer. That's in the interval. So I can say theta then. One answer. The solution to this equation is 2.08. Rounding out to two places. So here we go. You can see this value is larger than 1.57 and less than pi or 3.14. So that angle is somewhere over here in quadrant 2. That's where the tangent is negative, because the x is negative, the y is positive. But a y, positive y over a negative x is going to give me a negative. And that's what I want here. I got a negative 9 fifths. In quadrant 1, everything's positive. That won't work. Now in quadrant 2, could the angle be over here? Well, in this case, the x is negative and the y is negative. A negative over a negative. Remember, the tangent is defined by y over x, or xy is the point on the terminal side. That's not going to work. So it has to be an angle over here in quadrant 4. Because in quadrant 4, the x is positive, but the y is negative. Negative over a positive is a negative. So basically, I want this angle here. So to get it, I need to know this angle. And then all I would have to do is subtract that reference angle from 2 pi. Well, it turns out the reference angle is just going to be this right here. Just ignore the sign, and that's a 1.06 and so forth. So what I'll do is write it over here. The reference angle is 1.066369. I'll just use 70 decimal places. So to get the final solution to this one, I'll simply take 2 pi and subtract this value right here of 1.06369. Hit enter. There it is. Run that out to 2 places. This then will give me a 5.22. So the two answers for this equation in the interval from 0 to 2 pi are 2 and 5.22. Thanks for watching. We'll see you next time.